Welcome to the project demonstration of solar outdoor air purifier. So the main features of this project is we are using a outdoor air purifier with a HEPA filter and 4 exhaust fans. So these 2 fans will take the air from the outside of this environment and that will be filtered. So inside this we have used a HEPA filter over here. So you can see that. Okay, so this HEPA filter will filter that, and the first one is like normal high particles which can be filtered by this one, and remaining nanoparticles so which are not filtered in the outside filter, so that will be filtered by this HEPA filter. So this HEPA filter will filter the remaining minute components, and output of this will be given as input to the exhaust fans, and the output of this chamber is purified air. So that output directly coming from these 2 exhaust fans will take the purified air inside this chamber and will be being outside. And this system getting power supply from this battery pack which can be rechargeable by this solar panel, as well as whenever the sunlight is not available we can charge this battery pack with the help of this transformer. And these so-called exhaust fans will be controlled based on the air quality. So to measure this and to control these exhaust fans we are making use of Arduino Uno, and we shall taking input from this MQ7 MQ135. So harmful gases will be detected by this one, and next the air quality will be measured by this MQ135. So whenever this is abnormal, then automatically these 2 fans along with the backside fans will be controlled directly with the help of this relay, so that the outside air will be purified in 2 stages, in filtration as well as in the HEPA filtration. So then directly we will get the purified air from this chamber directly. And so-called status of these 2 sensors continuously displayed on the LCD screen, and also same will be uploaded to the ThingSpeak with help of ESP8266 Wi-Fi module. So this can be accessed from anywhere in the world, directly log into the ThingSpeak cloud platform. So these are the main features of this project. Coming to the components, so solar panel we are using 12 volts. So if you are over the own solar panels directly we can connect that. So like here S we have written here. So connect this solar panel here one. So if you are the customized solar panel, we are going to provide this 2 pin. So you can place this wire negative of the solar panel, and this is positive of the solar panel. So whenever the sunlight is not available, we can charge a battery pack with the help of these charging circuits using this transformer. We will provide this. And here these 2 charging circuits look like same. So it has the mainly 3 stages. One is rectification. If we provide the AC inputs, these 4 diodes will act as a rectifier, so which is used to convert the AC to DC. And but in coming to this 4 diodes on this solar panel charging circuits, so these 4 diodes will acting as a polarity correctors. So if by mistake if we connect these 2 wires in reverse polarity, then this particular rectifier will rectify that plus to plus, minus to minus, and after that filtration. And next is 2 diodes will acting as a unidirectional current flow. Means whenever the battery got full charged, so in order to protect the sources from the overcharging and reverse current protection, they are going to use the 2 diodes which will protect the battery from overcharging protection, as well as solar panel and transformer from the reverse current protection. So this battery we are using the 12 volt 2 amp battery pack. So this battery pack consists of 6 4 volt 1 amp batteries. In that these 3 are in series, so we'll get 12 volt 1 amp. These 3 are in series, so we'll get 12 volt 1 amp. These 2 are in parallel, so we'll get 12 volt 2 amp DC output. So that DC output is input to this system through this LM2596 voltage regulator. There we can see the LM2596 voltage regulator. So the input of this voltage regulator is 12 volts DC. Parallelly the same 12 volts DC is input to this exhaust fans with the help of this electromagnetic relay. When the relay gets switched on, the 12 volt supply is given to these fans. And so the output of this LM2596 voltage regulator is 5 volts. So that is operating voltage to our microcontroller, that is nothing but Arduino Nano board, and ESP8266 Wi-Fi module. This is ESP8266 and MQ135 MQ7 sensor, and this is the breadboard to distribute the 5 volts power supply throughout this input output modules of our project. And output module is LCD display. Coming to the interfacing connections, so we have interface this sensor MQ7 at A0, MQ135 at A1, 8 and 9 pins for this ESP8266 Wi-Fi module, 10th pin for this relay, and pin number 2 to 7 for the 16:2 LCD screen. So these are all the input output connections and features of the project. Let us see the demonstration. So before on the kit, we need to provide the hotspot to the kit. So using the hotspot only, the system will upload the data to the ThinkSpeak. For that, go to hotspot settings of your phone and configure the hotspot name to project 7329. All are small letters without any space, without any capital letter. Password should be 123456789. AP band should be 2.4 gigahertz. After successfully enabling the hotspot and data, you can just log into the ThinkSpeak. Stay on the screen. So this is the previous data which we have got this while we testing of the project. So if you want to get the fresh data, we can erase this. But before erase that, better to take it back up. Go to data import exports, and in that download the data. The data will be downloaded in Excel sheet format, and we can access that. So which consists of date and time along with number of samples till now we have collected. So date and time, so we have collected 7 samples. The first one is the LPG gas, second one is air quality. So these are the ppm, that is the parts per million. Okay, so that was measured in MQ Sensors data. After we took the backup, now go to channel settings. In that, only do clear channel, right? Okay, clear the channel. Then after the channel cut will be cleared, and go to private view to access the live data of the project, the sensors. Now the old data got erased. So after this, now on the power supply to the kit. So generally we can place the whole kit inside the chamber. Just for demonstration purpose, I am showing this by keeping the outside, by explaining the each and every component. Just on the power supply. Yeah, let us actually, before demonstration, one more thing is we need to keep the battery under charging either from the solar panel or transformer. Just keep the battery supply for charge from the charger. So there we can see the light indication. Same for the solar panel also. If we place the solar panel over here, then we can see the light indication. Due to the low light intensity on the solar panel, we are not getting the sufficient lighting from that. You can see that we are getting low intensity. If you place the total solar panel on the outside in sunlight, then you will get more light intensity as this transformer is providing. So the charging time for the solar panel, from the solar panel or from the transformer, it's 5 hours to be fully charged of this battery pack. So the whole system getting run by the only battery. Now this is the main on off switch. Just on the switch. So welcome to the project initially displayed, and after that the Wi-Fi module is getting connected. We can see the blue lighting is blinking. So once the Wi-Fi module is installed successfully, then we can see the gas, air and this ppm values. So initially they'll get heat up. So as we can hear the sound, the relay got switched on, and whenever these values are less than the abnormal values, so whenever the air quality is less than 450 ppm, that is a normal value, and above 450 ppm, that's abnormal value. Coming to the gas, whenever it is above 150 ppm, it's abnormal value. So we can observe that. Now we can see the data is uploading to this ThinkSpeak, right? So when you click on this dot, you will get the gas and date and time. This ppm value, this air quality ppm value, right? Just we are going to make input from this. Okay, this air quality. So on LCD we can see that it got increased, and the fan got switched on. You can see that it is taking the input to this. Now you can place this inside the chamber and demonstrate that. Let us place the whole kit inside the chamber. Right, now we have placed everything inside the chamber. Okay, and now so everything is normal. The fans got switched off, sorry. So you can see the data is continuously streaming to this ThinkSpeak cloud platform. Okay, same time, right? It's uploading that. Now let us just provide this input to this smoke sensor. Gently provide that. So you can see when it is crossed 450, then automatically the fan got switched on. That's why it's drastically reduced again. So you can see that. right, okay, it is filtered. So when it is 400 below, again it's getting off. So like this we are going to do the filtration in outdoor air purifier with the help of this HEPA filter. And right, so let us check with LPG gas input. So just we are providing input to that, and we can see the ppm got increased. Right, okay, as you can hear the sound also, the fan got switched on and it start doing the filtration process. Right, okay. So if you want to make the sensors to be kept outside, you can keep them outside of this chamber, or else you can keep the inside of them to check with the air quality inside that. Right, thank you.